We're going to do a combustion example now. Just like the last question on your exam. I stole the last question from the practice exam. Need that out of the way. Thank you. Okay. And I edited it. So it's a whole new question now, even though the number stayed the same. So how do you start this question? You're only given the formula of the fuel. You should know. You copy the fuel. And you have to provide the other reactant and the other two products. What is the other reactant? You can't have fire without what also present? O2. Always make CO2 and water. So those green pieces you have to come up with on the test. You know it's happening. Please be ready for it. So now it's balancing time. And I mean, we've been sticking with start with carbon. There's nothing wrong with doing that every time. Doesn't this fix the carbon situation? How about the hydrogen situation? Looks pretty bleak. We need a 6 and then it's fixed. After you've done that one, count your oxygens. That's why I write oxygen here so you know what this means. 10 molecules of CO2, how many oxygens? And 6 molecules of water, how many oxygens? What's half of 26? Put it over here, done. And that was 4 points. That's big. That's 4 of your faster points, I think, for your exam, isn't it? So I think that part's easier than the previous question's first part. Then the rest, because you have to figure out excess and limiting, makes it a little harder. Yeah, when the excess limiting thing's hard, but follow my hint and it's not. Yes. So she has actually found a shortcut that you would use maybe even on the practice exam version where half of this number turns out being odd, which puts an odd number there, which puts an odd number here, which means everything's going to be multiplied by 2 in the end. But guys, just ignore what I said. It doesn't matter. If you get a fraction, double everything and you're done. We didn't get a fraction. We don't need to double everything. We're already done. Okay? There's your 2 scenarios for every combustion reaction ever. You're either doubling because you had a fraction, or you're leaving as is because you don't have a fraction. There's fractions for any possible balancing reaction, but we typically don't make you do a lot of fractions at this level. So the only fractions we have experienced have been at the combustion reaction type question, but they can occur at any time. I'm just telling you. All right, determine how many moles of that and oxygen are being reacted. So 2 parts to this. I think on the practice exam, I have little dividing lines because I'm going to do the fuel on the left and the oxygen on the right. O2, I need the FW. And guys, you're going to need fuel, FW, and O2, FW guaranteed here. That's where you start part B. The fuel formula is up here. 10 carbons, right? 12.01 plus 12 times 1.008. So I've got 120.1 plus 12 is 132.1, and it's going to round up to something higher. Maybe. You're going to do it for me? Need that number after decimal. Might be 0.2, might be 0.1, don't know. I would. So it's a 2. You can keep 196. Oh, guys, the double line is in the way. Yeah, it needs to shrink. What are the units for this number? Wow, it's only the first time he's asked it today. Thank you. Okay, now you can go to moles. How many grams of oxygen are, no, it's not oxygen. How many grams of fuel are being reacted? Fuel. Dude, there's not a 32 anywhere. Just say. He said 32. 56.78. Okay. All right. That was random, man. I liked it. 56.78. Don't remind me of an old TV show. The answer to every question is 42. Hitchhiker's Guide. All right. Got to convert that to moles. I need moles on top. Getting rid of grams on the bottom. We have everything we need to the right. What goes in front of grams? 132.2. Don't know how that happened. 132.2 for every 1 mole. And it's over a third. That's good. I like it. And that's moles of yeah, moles. Can I just write fuel? You can use the word fuel in case you don't want to write that formula out over and over. It's better. I think it's better if you write the formula C10H12. I agree. Start up over here. You guys, just don't write down 32 grams per mole here. Don't do that. Don't. I mean, where's 32 grams per mole come from? It's not on the periodic table. And you're supposed to show your work for every math operation you do on this exam. I'm going to hit you for a quarter point if you just write down O2 formula weight 32 grams per mole. You didn't show your work. How did you figure out O2's formula weight is 32 grams per mole? 2 times 16. 2 oxygens, 16 grams per mole each. What are the units for this number? Thank you. How many grams of oxygen are in the question? 32? No, I'm messing with you. 76.54. Times 1 mole for 32 grams. Equals, that's over 2. 2 point something mole O2. I need a lot more sig figs than that, guys. 2.760. 391. 392. Minimum of 4 sig figs. Good. So yeah, those are final answers, so they better be 4 sig figs. Okay. Now don't try to tell me which one's excess and which one's limiting just looking at those numbers. Those are not good. Those are apples and oranges right now. We need to compare precipitate to precipitate, or in this case, CO2 to CO2. It's not a precipitate question. How do you know CO2 is the molecule you should be going towards now? In part C, and I will be guiding you towards CO2 in your part C as well. Okay, so here's the hint, determine the number of moles of carbon dioxide that can be formed from each reactant first. Go from moles of fuel to moles of CO2 using what? Moles of A to moles of B using what? Coefficients. It's finally time to use the coefficients. You have not used a single coefficient till now. If you do use a coefficient before now, you're going to be losing points. Okay, so 0.4295 mole fuel. I'm going to write down C10H12. Coefficient time, mole C210H12 for mole CO2 on top. 10 moles CO2 are made for 1 mole of C10H12 reactant. 4.295. Yeah. Yes. Correct. So that is actually in the hint, it says to do that, right? Now, what about 2.392 moles O2 making CO2? I need 10 moles CO2 and I need 13 moles of O2 and moles in black. Moles of CO2 for every 13 moles of O2. Yes, sir. A for what? 0? Okay. 4 sig figs. I had to throw the 0 there for you. And that is the only important number of these two numbers. Why is that the important number? Well, how do you know it's the number you're looking for? Compare that one to the other moles of CO2. The lower one tells you that after you've made this many moles of CO2, your oxygen's gone. What do you call oxygen? This is the theoretical yield. And therefore, O2 is limiting. It asked that, didn't it? Which reactant is limiting? O2 is limiting. What do you call the other one? The fuel. Don't call it limiting. There's extra of it. What's the word? Excess reactant. I didn't ask for excess reactant, but I could, but I didn't, and I won't. Because only the limiting is the important one. Excess is extra. We got enough extra in life today. All right, guess what? You have the theoretical yield in moles, and in the actual yield, they gave it in grams, right? Can you read the top of the page? Actual CO2, just read it for me. 23.45 G. Percent's got to be actual over theoretical with matching units. When we did it last time, was it moles over moles or grams? Yeah, let's do grams over grams this time. Okay, I got one of them in grams. The other one needs to become grams because you decided that. Convert 1.840 moles CO2 to grams. And to convert anything to grams, you need what? Formula weight CO2. Don't just write down 44.01 grams per mole. You're going to lose a quarter point. You didn't show me how. 12.01. 2 times 16.00. 44.01. And what are the units? Grams per mole. And we're going to take the moles up in 1.84 and make it into grams. 1.840 mole CO2 times 1 mole on the bottom. And how many grams on top? Yeah. I didn't get invited to the party back there. Yeah. Okay. So what do we got? Big. It's going to be close to 70. Okay, closer to 80. 80 what? Careful. 970. And that's grams on the top. Moles are a thing of the past. Don't forget, this was the thuld. What's the thuld? Theoretical yield. I got it right from this theoretical yield. There's just two ways of saying the theoretical yield. You can say it in moles. You can say it in grams. Percent, hit me up. No, actual over theoretical. You never get, well, only in lab do we get more than 100% for reasons that are lab reasons. 2345 is the actual grams. 80.978 was the theoretical grams. I need a percent with no units. Grams over grams, units are gone, percent. It's going to be less than 50, less than 40. I'm going out 30 something. No, don't make up numbers. Oh, yeah, 28 point who? 9. Percent. You did. You did it first. Nice job. There's a lot. That's our biggest question on the exam. And that's